In this video, we will be going over the answers to Grade 6, Chapter 9, Area, Lesson 4, Changes in Dimension, Independent Practice, pages 701 through 702. Lesson 4, Question 1. Now, for Lesson 4, I strongly recommend having a calculator. The numbers and stuff are easy to multiply and divide, but we're not really concerned with your arithmetic ability. Rather, we're concerned about some conceptual ideas that will be easier to understand if you don't have to worry about calculation. So if you don't have a calculator, you can use your cell phone, or there's some things online, but I do recommend using a calculator for this portion or this lesson. So, question number 1. Each side length of the parallelogram at the right is multiplied by 4. Describe the change in the perimeter. Justify your answer. So first things first, if I take a shape and I multiply each side by 4, is the shape going to get larger or smaller? It is going to get larger. So our shape starts off like this and it's going to get larger. So at this time, draw the second shape. So we're going to multiply each side by 4. And I'm going to change colors here. All right, times 4 equals 32 centimeters times 4 equals 40 centimeters. Now, the perimeter is the next thing they want us to solve for. So, opposite sides of a parallelogram are the same length. So we have 10 centimeters and 8 centimeters. And then here we have 40 centimeters and 32 centimeters. So the perimeter of the blue shape, you would do 10 plus 10 is 20, 8 plus 8 is 16, and if you add that together, you should get 36 centimeters. Now you might be asking yourself, why isn't this centimeters squared, or in this case there's 4, so why isn't it centimeters to the 4th power? Remember, perimeter is the measure of length, and that's only one dimension. If I were to cut the perimeter here and lay it out, it would be 10 centimeters, 8 centimeters, 10 centimeters, 8 centimeters. So I have a total of 36 centimeters from one side to the other, but it's only one dimension length. A line only has length. It doesn't have width or height. It's just one dimension, and therefore that's why we only have centimeters. So remember, perimeter is only a centimeter measurement. Or just, no, it's not squared. All right, so now over here, 40 plus 40 is 80, plus 64 equals 144. So the perimeter of my enlargement is 144 centimeters. Okay, so in our directions, they said to multiply the sides by 4. So we multiplied each side by 4. What did this do to the perimeter? What do I have to multiply the perimeter by to get my new perimeter? Well, to do this, you do 144 divided by 36, and you will get 4. So 36 times 4 is 144. So when you increase the size of each side by a factor of 4, that increases the perimeter also by a factor of 4. The perimeter is 4 times greater. The perimeter of the original figure is 36 centimeters, and the perimeter of the new figure is 144 centimeters. 144 centimeters divided by 36 centimeters equals 4. Question 2. The base and height of the triangle at the right are multiplied by 4. Describe the change in the area and justify your answer. Okay, so we're again multiplying by 4. So is our triangle going to get larger or smaller? It's going to get larger. So here's our original, and then here is our enlargement. We're supposed to multiply the dimensions by 4. Okay, so I'm going to multiply 6 times 4, and that's going to give me 24 meters. And 5 times 4 is going to give me a height of 20 meters. All right, so they want us to figure out how the area changes. Now, we have increased the size of the dimensions by 4. We multiplied times 4. Okay, we want to know, how does this impact the area? So here we have our formula, and I'm going to do the first triangle. Area equals 1/2 times 6 times 5. Area equals 3 times 5. So the area equals 15 meters squared. Now let's do the other one. Area, I'm going to change my color. Area equals 1/2 times 24 times 20. Now I'm going to do this a little bit out of order. I'm going to do 1/2 times 20, which is 10, times 24. So the area equals 240 meters squared. So let's see. In our last problem, when I multiplied each side by 4, the perimeter also increased by 4. Is that the case here? If I multiply 15 times 4, am I going to get 240? 15 times 4 equals 60. It does not equal 240. So what do I have to multiply 15 by? Let me get my highlighter. What do I have to multiply 15 by to get 240? Well, put 240 in your calculator, divide it by 15, and you'll get 16. So why is that happening? I want you to take a look at this square. Okay, what is 4 squared? 4 squared equals 16. Remember how our perimeter wasn't squared? It was just the plain old unit? Well, area is a square unit, so we have to square the factor of enlargement. So if we enlarge something by a factor of 4, we have to do 4 squared to find the new area. The area is 4 squared, or 16 times greater. The area of the original figure is 50 meters squared, and the area of the new figure is 240 meters squared. 240 meters squared divided by 15 meters squared equals 16. Question number 3. Each side length of Question 4. Different sizes of regular pentagons are used in a stained glass window. Each small pentagon has side lengths of 4 inches and an area of 27.5 square inches. Each large pentagon has side lengths of 8 inches. What is the area of each large pentagon? So here we have our two pentagons, and we were just told that the area of our smaller pentagon is, let's see here, 27.5 inches squared. And now we have to figure out what the area of our larger green pentagon is. So that's our missing number. Now, our shape is getting larger by a factor of 2. 4 times 2 equals 8. To get from area to area, we have a squared unit, so we need to square 2. So we need to multiply by 2 squared, which is 2 times 2, which equals 4. So we have to multiply by 4. 27.5 times 4. And that equals 110 inches squared. Question 5. A dollhouse has a bed with dimensions 1/12 the size of a queen-sized bed. A queen-sized bed has an area of 4,800 square inches and a length of 80 inches. What are the side lengths of the dollhouse bed? Justify your answer. We have a regular queen-size bed, and then we have a dollhouse bed. To get from the queen-size bed to the dollhouse bed, we are going to multiply by 1/12, which, like I said before, is the same as dividing by 12. A queen-size bed has an area of 4,800 inches squared. The length is 80 inches. What are the side lengths of the dollhouse bed? Now this is going to take us some calculations, all right? So let's work with the the queen size bed first, all right? So I'm going to use this color blue to indicate that. So area equals the base times the height. So 4,800 inches squared equals the base times 80 inches. Now I'm going to divide by 80. Divide by 80 inches. So the base equals 60 inches. So down here, I'm going to write 60 inches. All right, so so the queen, let's go back here. A dollhouse bed has a dollhouse has a bed with dimensions 1/12 the size of the queen size bed. So I'm going to multiply 80 times 1/12 and 60 by 1/12. And again, that's just dividing by 12. So in your calculator, you can put 80 divided by 12 equals 9, sorry, I multiplied, sorry. 80 divided by 12 equals 6.6 repeating. And then this would be 60 divided by 12 is 5 inches. Okay, now we're going to multiply 6.6 repeating times 5, and you get 33. The area equals 33.3 repeating inches squared. Okay. Use the area and the length to find the width of the queen size bed. The width of the bed is 4,800 divided by 80, or 60 inches. So the width of the dollhouse bed is 60 times 1/12, or 5 inches. The length of the dollhouse bed is 80 times 1/12, or 6 2/3 inches, which is what we have, but we just have it as a decimal. Question number 6. Reason abstractly. Refer to the graphic novel frame below for exercise B. We need to figure out how the area changes if the lengths of each side is 2 times greater. So if each side length is 2 times greater, is it going to be larger or smaller than the original? It's going to be larger. And let me just erase my ink. All right, what is the original area of the triangle? Original area of the triangle. So we have area equals 1/2 times 40 feet times 30 feet. Area equals 20 feet times 30 feet. Area equals 600 feet squared. All right, and what is the area of the new, what is the new area if the sides are all 2 times longer? So let's see, where'd my pen go? Sometimes I lose my pen here. Yeah, 40 times 2 is 80. And 30 times 2 is 60. So area equals 1/2 times 80 feet times 60 feet. Area equals 40 feet times 60 feet. Area equals 2,400 feet squared. All right, let's check our answers. 600 feet squared, 2,400 feet squared. Question 7. Sketch a triangle with the side lengths labeled. Sketch and label another triangle that has a perimeter 2 times greater than the perimeter of the first triangle. So in order to get a perimeter 2 times greater, the side lengths each have to be 2 times bigger. So for example, we could have a triangle that's 1 by 1 by 1, and then the next one will be 2 by 2 by 2, because the perimeter here would be 3 centimeters, and the perimeter here would be 6 centimeters, which is 2 times greater. But really, whatever triangle you drew, as long as the side lengths are 2 times greater, so this would be 33, let's say it was centimeters, and this is 66 centimeters. Sorry, this should have been an arrow. That would be 2 times greater. Question 8. Persevere with problems. The corresponding side lengths of two figures have a ratio of A to B. What is the ratio of the perimeters? The ratio of the areas. Okay, so here we have A, and here we have B. So let's say that we multiplied A times 2 to get B. But we would do the same thing with the perimeter. Okay, so if the ratio is A to B for the sides, for the perimeter, the ratio is also going to be the same, A to B, because it was going to be exactly 2 times. So if we increase the side lengths by 2, the perimeter is increased by 2. Now for area though, if we increase the size of the sides by 2, we have to increase the area by 2 squared. So that means it would be A squared over B squared. That's the ratio. Not an entirely important question to understand, okay? For those of you who get it, that's great. If you don't worry about it. Question 9, reason inductively. The larger square shown has a perimeter of 48 units. The smaller square inside has a perimeter that is 2 times smaller. What are the side lengths of the larger and smaller square? Well, the one thing we know about squares is that all the sides are the same length, okay? So the big square has a perimeter of 48. Well, a square has 4 sides, so I needed to do 48 divided by 4, which gives me 1, 2, 12. So this square is 12 units by 12 units by 12 units and 12 units. Okay, so every length is 12. Now the smaller square inside has a perimeter that is 2 times smaller. So that means whatever is here, I multiply by 2 to get 12. So what do I have to multiply by 2 to get 12? 6. So the size of the sides inside for the smaller square are all 6. So what are the side lengths of the larger and smaller square? Larger square is 12 units, smaller square 6 units. Sample answer. The lengths of a square's sides are equal. Divide 48 by 4 to get a side length of 12. The side length of the smaller square is half as big, so 6 units. And this brings us to the end of our lesson. I want you to enjoy the rest of your day. This is Mrs. Smith signing off.